Well, thank you, Michaela, and thank you for everyone for taking time out of your day or evening today to join us. And we welcome you to the webinar today, Belimo Energy Valve One Complete Optimized Solution. This here webinar is going to have some overview of the features and benefits of the Energy Valve. The Energy Valve is now a IoT device leveraging IoT technology. And we have an advanced suite of cloud analytics that we utilize. You can see some of the orange clouds in the background. So I'm going to be covering that as well. And giving you kind of an overall experience of the Energy Valve for those of you that are not as familiar as well. So without further ado, I'd like to get right into the presentation. I'd like to first start with an overview for those of you that are not that familiar with the Energy Valve. The first component that I'd like to talk about is the actuator. The actuator is the most advanced actuator in the Belimo platform, and there's a lot going on in that little actuator on top of it controlling the valve. First component is a integrated web server. This allows us to connect to the Energy Valve over any IP network. There are valves located all over the world that I'm able to access sitting right here at my desk in Danbury, Connecticut. This is very helpful for us in terms of our technical support utilizes this from a troubleshooting standpoint. We also utilize this for customer training. It's very good sometimes to see a valve in operation and have somebody on the other end to kind of guide you through what's happening with the valve and how to make any appropriate changes. There's a built-in data logger that stores 13 months worth of trended data on the valve operation, which would be data on flow, on energy, on power consumption, on delta T, supply water temperature, return water temperature. All of that data is stored for 13 months and can be exported out of as a standard CSV file, and that can be utilized for further means, some of which I'm going to talk about a little bit later in this webinar. It has integrated BACnet, both IP and BACnet MSTP, allowing for integration with the building automation system, and it also has Modbus as well. That was a fairly new addition to the Energy Valve, so both Modbus IP and Modbus RTU. So we have over 50 data points that we can pull back to the BMS through the Modbus and BACnet protocols, allowing for a nice integration into the BMS side as well. We have an MP bus protocol. That's a Belimo protocol that utilizes sort of a master and slave configuration to have multiple valves controlled off a single control point. And we also have a very interesting feature integrated as well called Glycol Monitoring, which allows us to extrapolate the exact glycol percentage within a system. So if the system is run at 20 or 30% glycol, that is actually output in the interface of the web server. I'm going to talk a little bit more about that coming up. Next component I'd like to talk about is the flow meter. It's an electronic flow meter, which means it produces a true flow as opposed to a calculation based on valve position and delta P. So we have an actual flow rate of what's going on through the valve. Very helpful in terms of commissioning. That way it doesn't require taking a pressure drop across a coil with a traditional method. You actually have a verified flow rate, which can be, there's also a performance, a report that can be provided to indicate what the setup is that allows a commissioning report that can be produced through the actuator that actually shows what the actual flow rates were and the actual actuator position and valve operation and so forth that can be used for commissioning purposes as well. It's an ultrasonic transit time design, a very robust design with no moving parts like a paddle style wheel that could become clogged with debris over time. So it's a very robust and accurate design. We have temperature sensors, supply and return temperature sensors. This allows us to measure the delta T across a coil. These are platinum-based PT1000 RTDs. We specifically chose RTDs because they're very good for measuring specific temperatures and they're very high quality. So with the flow meter having flow rate constant and delta T, we are able to extrapolate BTUs as well. So when this not only is a control valve, it also can be used as a BTU meter as well. So it's another feature integrated directly into the Belimo Energy Valve. The last piece that I'd like to talk about is the logic. There's a delta T manager located in the actuator, and what that does is optimizes coil efficiency by maintaining the appropriate delta T, eliminating overflow through the coil, which is thus in turn optimizing the overall efficiency of the coil and of the overall system. We have a cloud optimization integrated into this as well. I'm going to talk a little bit later about our suite of cloud services that are integrated within the product. And we also have what's called a power control algorithm. This allows the valve to be controlled instead of with a flow set point at a Vmax, allows it to be controlled at a power set point or a Pmax. So the valve is not only pressure independent, it's also temperature independent as well. So that's a basic overview of the Belimo Energy Valve. Here at Belimo, we have a focus on energy optimization. A lot of our products are designed with very low power consumption. Our zone-tight actuators use some of the lowest VA consumption in the marketplace. You'll see some of the same design characteristics in our butterfly valve as well. And the Belimo Energy Valve follows suit in terms of focus on energy optimization as well. And the reason is because it's really good for the environment. Buildings are an integral part of the global energy system, and some statistics on those buildings, they use about 40% of the global energy, 25% of the global water, 40% of global resources, and they emit 1/3 of greenhouse gases. And the area where you like to focus is in the HVAC system, and they're according to LEED that about 39% of the building's energy use is for the HVAC system. So that's where we're going to focus some of our discussions today. And when it comes to the HVAC system, the one area that we're talking about is what's called low delta T syndrome. So that is, there's a high awareness of low delta T syndrome. If you were to Google that, you would come up with a little over 13 million results. And essentially what low delta T syndrome is coils operating at an inefficient level by not maintaining their delta T set point. There's been numerous articles that are been written about low delta T. Many of our customers have talked to us about the low delta T syndrome, so they were aware of this and inefficiencies in their plants and they're dovetailing back to their buildings. And it's one of the reasons that Energy Valve has been so successful. One of the things that makes a product really successful is when the product solves a core problem in the marketplace. It's always good when you have additional features to go along with that, but when you're solving a customer pain point, that's one of the really drivers for growth and sustainability of a product. So let's talk a little bit about low delta T syndrome and how that may occur. There'll be a couple of ways here. There's not all exhaustive list, but I just want to give you a little bit of an overview. First one is when coils and valves are not sized properly. This here, we're talking mainly about pressure dependent valves. Pressure dependent valves are typically sized on CV, and when that CV is typically calculated within the system, that CV is not always available in the product catalog. So what tends to happen is a CV higher than what is needed is selected, and that valve is inherently oversized out of the gate. So the valve is already essentially overflowing from day one of installation. Same thing with coils. Coils are typically oversized as well. There's typically safety factors built into coils, so the coils are inherently oversized as well. So overflowing valves and oversized coils is a symptom for low delta T syndrome. Systems are not dynamically balanced. Here we're talking about pressure dependent valves as well, so not having pressure independent valves in the system. So the valves are at the mercy of the pressure fluctuations within the system. The valves are going to overflow and underflow as pressures oscillate within a system. Coils foul and degrade with age or lack of proper maintenance. Coils are constructed of stainless steel or other metals, and those metals wear over time. Those coils can become dirty, over time, and that would have a negative effect on the heat transfer profile of the coil. Sometimes coils are cleaned, and because there's a layer of dust that builds up over the coil surface, and the technician may accidentally bend the fins of the coil, and those fins are designed at a specific geometry to the tubes, and if that geometry is changed, that once again has a negative effect on overall heat transfer of the coil, having a negative effect on the performance as well. So essentially what we're talking about is too much water being delivered to the coil. So basically overflow of the coil, creating a low delta T syndrome. This here is another description of the of low delta T, and I'd like to talk to you here a little bit about the relationship between flow and delta T. This is a very simple chart. On the x-axis, we have flow and GPM. The y-axis on the right, we have delta T in degrees Fahrenheit. And the y-axis on the left, we have power in BTUs. These red squares here are representative of a power curve of a coil, and all the red squares represent data points, and they're normalized with the yellow best fit line. And you can see there's a fairly wide power band that a coil has to work with. So there's a fairly wide area of power for that coil to work in. Delta T, same type of description here. The dark blue squares are all data points, and they've been normalized with a lighter blue best fit line there as well. So in this case, we're going to talk about how the energy valve can help in terms of the delta T manager. So in this case here, the delta T manager has determined that the best delta T set point for this coil is 12 degrees. At one particular flow point at around 64 GPM, we can see that we're below our delta T set point at around a 10 degree mark and flowing around 325,000 BTUs per hour. What the delta T manager would do would modulate flow down to bring our delta T set point back up to our desired delta T set point of 12 degrees. So a lower flow rate while still meeting the load within the space. So a higher delta T means a more efficient heat transfer. So essentially what we're doing is using less water to address the load, utilizing that wide power band within the coil itself. So that is one of the key features of the energy valve, because if you're using less water to satisfy that load, that's going to have a big effect on pumping energy. You're going to be using less pump horsepower, less pump head throughout the system. And because you're using less water, that could possibly mean that you could be turning off chillers, using one chiller instead of two, or two chillers instead of three. And by that effect there as well, you also be shutting down cooling towers, and the efficiency savings on the pumping side there as well on the condenser side. So essentially what we do is use less water to address the load within the space. So another way that the energy valve can help is by utilizing advanced ultrasonic technology. I talked a little bit about that on the opening slide, but I'd like to go into a little more detail here. Each one of these ultrasonic sensors is individually wet calibrated to ensure accuracy and repeatability. It's calculated for flow, both flow and temperature. We have a very high rangeability within these of 100 to 1. They are temperature and glycol compensation. There's an algorithm in there. The ultrasonic sensor utilizes an integral temperature sensor that monitors the change in temperature and the glycol compensation and maintains our accuracy by seeing the differences in those to make sure that everything is operating according to specification. And we also have glycol monitoring. Like I said before, the glycol monitoring allows to extrapolate the exact glycol percentage within a system. Utilizes the transit time technology, understanding the flow rate through the flow meter and the temperature, and there's a cross-reference table in the actuator that looks at the combination of those two and is able to extrapolate the glycol percentage within a system. So whether it be 30%, or 40%, or 20%, that can be output through the web server, and there's also a backnet point to go back to the system. So there's some key benefits when we talk about glycol monitoring, and they're basically tied around efficiency and pumping efficiency. Pumping efficiency and glycol concentration kind of go hand in hand. As our glycol concentration increases within the system, our pump efficiency goes down. Because as glycol content increases, the media becomes thicker, more viscous, or there's more viscosity to the media. We're increasing that viscosity, we're increasing the pressure drop. It takes more pump head to pump that thicker media around the building, having a negative effect on the pumping efficiency. And then once again, in creating additional pumping requirements to pump around that thicker media throughout the building, once again having a negative effect on the overall efficiency of the pumping throughout the system. It optimizes heat exchange. Maintaining glycol concentration at design levels is very critical for maintaining proper heat exchange through the heat exchanger. We've seen cases where customers have had glycol concentrations in excess of design, 50, 60, some higher percentages of glycol within the system, and they're unable to meet discharge air. Move that down to the appropriate design conditions of 30%, and they're immediately able to discharge air. Everything was operating correctly within the system. It was just an overabundance of a glycol concentration within the system having a negative effect on the coil. Most natural is probably a safe operation. By having glycol, it prevents pipes and components from freezing, allowing for safe operation within the system. And the last one is there's a financial savings. A financial savings in terms of having this all incorporated into one user-friendly device. If you needed a glycol monitoring that would report back to the BMS, that would require a separate refractometer and a separate control point for that to go back to the BMS. Here with the Energy Valve, it's all integrated with a single control point and can be integrated back to the BMS. So you have the cost savings of not having to add an additional control point, and you also have the cost savings of not having to add an additional refractometer within the system because it's all built into the Energy Valve. As I mentioned before, the Energy Valve is a IoT device utilizing cloud analytics to provide advanced optimization with multiple benefits. So now I'd like to talk to you a little bit about our suite of cloud services that we offer. The first one is optimization of delta T and flow set points. So this here, the Energy Valve can be run for a while in the Belimo cloud, and a request can be made for the best delta T and flow set points, and that recommendation will be provided via our Belimo cloud, either directly to the device or to the end user to be loaded into the device itself, utilizing the system data to come up with the best delta T set point. This is very helpful because sometimes coils, 20, 30-year-old coils or older coils are not able to achieve the design delta T set point. They're not entirely sure where to set it. So this here is a very useful feature to help optimize the Energy Valve. Provide a performance report of key indicators, total energy consumption, if there's any errors within the system, how the valve has been operating. And I have a little description of that I'm going to show in an upcoming slide. Provide online support. This provides a very robust support experience for our customers. In the past, for our Energy Valves, we would request a screenshot of what was going on with the system. That screenshot would come in and some time would pass, sometime parameters would change. Now we can connect direct real time to the valve to provide a recommendation and see real time what's going on, which just provides a faster and more robust experience for our end users. Software updates. We have the ability to load software updates directly into the actuator itself. This is very helpful for sites that have hundreds of valves installed. Could you imagine how long it would take to update the software on 200 valves located throughout a building or multiple buildings? It would be a very time-consuming process, laborious process, inside, outside, on the roof, in the mechanical room, up in ceilings. Now it can all be done via the cloud, so it makes it much easier and much more efficient. We increase the warranty for another 2 years, activating the warranty total time to 7 years over the standard 5-year warranty of our standard product. And we also offer lifetime data access. As I talked about before, on board on the actuator is 13 months worth of trended data, but with the access to the cloud, there's lifetime data access. So one single, secure repository for all the system data that's located within the Energy Valve. An extension of the Belimo Cloud is something I'd like to talk about now. This is something that we're going to be releasing in the near term, and what's called an energy flow map, and it allows for visualization of where the energy is going within the system. So what it does is allows for valves that are on the Belimo Cloud to load a floor map, as you can see in the bottom right here, and you can map those valves installed on the Belimo Cloud to the flow map to show where loads are distributed within a building. So if in the first floor, second floor, etc. The building managers and energy managers, how they would utilize this that I've talked to is they would get the valves installed, load their flow map, and they would map the valves according to the flow map, and they would look at where the largest loads are first. And what they would do is that's the areas that they would concentrate on first. Is there additional opportunity in these areas for more optimization? Could the delta T set point be possibly set more aggressive? If there were, for example, a school environment, did the teacher possibly put a hot or cold rag over the thermostat, having artificial loads created in the system? So it just provides a little bit more visualization of where the energy is going. Also provides a dashboard of all the energy valves with key performance indicators of power, energy, flow, valve position, delta T, if there's any errors. So this is very helpful if there's multiple buildings or a lot of valves installed in the building, gives them a one snapshot view of what's operating and how the valves are operating within the system. And also provides some additional means for diagnosis. On the bottom left, you see some charting that we have there. So if, for example, if you wanted to chart DDC signal, valve position, and flow to understand if everything was operating correctly, because typically a signal of 100% to a valve and the valve was full open but not meeting flow is an indication that there's not enough pump head within the system. So additional diagnostic parameters within this as well. So not only a visualization, but also some additional diagnostic capabilities integrated into this energy flow map. So that's something we're very excited about as well. The performance report. This is what I alluded to earlier in our cloud services. Now this kind of simplifies data analysis for you. With having all the data up in the Belimo Cloud, this here gives one way to produce a very short and concise snapshot of what's going on in terms of operation, as the valve location, the valve name, the valve size, and key energy performance criteria. Total energy compared quarter versus quarter, cooling energy versus heating energy, how often the delta T manager has been utilized. So allows for a very concise document to help prove that the energy valve is operating correctly and saving energy within the building. For those that like to dig a little bit more into the data themselves, we also provide another means to assist as well. As I talked about, the energy valve stores 13 months worth of trended data that can be exported in a CSV format. And what we provide is a data analysis tool that helps that data come to life. That data can be imported into this data analysis tool, which is basically a macro to translate that CSV file into a more usable term than columnar format. So provide, once again, general information on what type of valve there is, the valve name and the valve size. A couple of snapshots here of flow analysis, so understand what the total flow has been through the valve, the average flow, the maximum flow, and also in terms of savings, there's an estimator that calculates the savings based on pump affinity laws. So when the delta T manager is enacted, it shows what the potential savings, what the savings is, what the delta T manager is in operation. Also has some nice charting as well to understand from an operational standpoint where the valve's been open. Has it been open 75% of the time, 25% of the time, and how often Delta T Manager has been in operation. A nice feature of this as well, this all produces a one-page consolidated report as well of the overall valve operation, so that can be utilized from a data analysis standpoint as well. So those are kind of after the valve's installed. In terms of estimating what the valve could save going in, we also provide one further tool, which is an Energy Valve Savings Estimator. And this is used before the valves are installed to estimate what the potential savings could be by installing energy valves on a particular project. So what this tool utilizes is a system parameters are put in based on the job. So the electricity costs for the area and kWh, information about the plant, how many types of chillers, how often those chillers are operated, pumping requirements, current delta T, future delta T, cost of the project, and that there will then put out a financial estimate on analysis of 5-year, 10-year, 15-year, or 20-year of what the savings could be over traditional valves installed within a project. So it gives us a way to estimate of how the energy valve could have an impact on the building. This tool was developed for us and validated with third-party energy conservation companies for validating formulas and so forth. So there's one more tool that can be utilized in the portfolio of the energy valve. So what we've really been talking about here is one solution with so many benefits. We talked about the Delta T Manager and how it's going to optimize overall coil efficiency. We've talked about the ultrasonic flow meter and the advanced technology there, and the ability to extrapolate glycol percentage, the web interface of allowing that to connect to valves located all over the building. We've talked about the cloud-based services. At its core, it is a pressure independent control valve, so it eliminates the need for hydronic balancing valves and circuit setters. So it's really one solution with multiple benefits. The last slide I'm going to leave you with today is one on industry recognition. We here at Belimo are very proud of the energy valve, but we're also very proud as well when it's been recognized by as many industry awards and customers as it's been. To date, we've received over 20 awards for the energy valve. Some of the most notable are the AHR Innovation Award in 2014, and then for a finalist in 2017. And our most recent was the 2018 Energy Genie Award, which is a global energy efficiency award. So like I said, we're very proud of it, but when it's really recognized by the recognition, it gives the product that much more credibility in the marketplace. Hope you found this webinar informative. If you need more information on the energy valve, go to our website at www.belimo.us. On the energy valve, there's plenty of case studies, further technical documentation. Attached in this webinar today is the brochure for the energy valve. Any additional information you could find on our website. I thank you for your time today and your participation, and I'd like to, at this time, open it up for any questions.
Great. Thank you so much, Scott. In order to ask a question, what you'll need to do is open up the question box, type in your question, I will read it aloud, and Scott will give you an answer as best as possible. We do have a couple moments left for questions, but if we are not able to get to those questions or comments that come about, we will reach out to you. As Scott said, we do have a handout available for today's webinar. It is the Energy Valve product brochure. And friendly reminder that this webinar has been recorded and will be posted to our YouTube page at a later time. So the first question is regarding MP bus. Could you have one valve on BACnet IP and the rest on the mechanical room networked on MP bus?
All design characteristics are specific to the site itself. It would be best to have a deeper discussion on that for the ways they can be configured. There's multiple ways to configure it. So I would, what I would like to do is take the information and have a further discussion on the best way to lay that product out into a specific site.
Great. I have sent your email over to that individual. Next question is the Glycol Monitoring available on all sizes?
Currently, the Glycol Monitoring is available on sizes 1/2 inch through 2 inch, soon to be in the entire range, so it'll be 1/2 inch through 6 inch, which would cover flows from 5 GPM all the way up to 713 GPM.
Okay. Are there any additional costs for the cloud services?
No, there's no additional cloud services. It's additional service that we provide to our customers as the overall experience of our products and our services as part of a partner with Belimo.
Okay, and this is kind of a follow-up question to that. Are there any extra costs for the data analysis tool?
No, that tool is located on our website and can be downloaded directly from belimo.us.
Okay. Can the older model energy valve be software, or can the older model of the energy valve be software updated without being connected to the internet? So.
No, the cloud services and updating of software is for versions 3 and above. So prior models do not have that capability and is not backwards compatible. So anything there's version 3 or later has that functionality, but nothing prior.
Getting a lot of questions coming through. Sorry, I'm just trying to filter them as best as possible. Next question is, can the energy valve be used in applications where the flows are over 713 GPM?
That's a really good question. Yes, it can. We can parallel energy valves, 2 or 3 energy valves. If you look on the cover of our current PGPL, you will see a parallel application with 3 energy valves installed. So yes, we can certainly do that to accommodate higher GPMs.
Okay. If the warranty increases to 7 years, does that include the valve as well?
Yes.
Okay. Can the online support from the cloud access the web view of my EV?
The web view is local to the product. The cloud interface is separate from that. If they were configured through a TCP/IP connection, they could do both, but the interfaces for the cloud and for the web view are unique and separate.
Okay. Does Belimo provide any assistance with valve programming and cloud setup?
Yes, we have a complete technical support team here, and we also have a complete sales force and regional application consultants that can help as well. And of course, I'm available as well.
Great. I'm going to do a last call for questions, and I know that we have a lot of questions and comments coming through. As I said, if we do not get to your question today, Scott will be provided a list of questions and email addresses, and we will reach out to you. So the last question, or the last couple of questions I want to ask are, Scott, can you talk further to the cloud and how safe it is regarding hacking?
We use state-of-the-art protocol. If you go onto our website, you will see a document that talks about all of the security measures that we enact. It would probably take another webinar to go through all of those. It's a very, very secure platform. So I would advise downloading that document, and if you have further questions, feel free to reach out to me directly.
Perfect. Okay, thank you everyone for participating in today's webinar. As always, thank you so much, Scott, for such an excellent presentation. Our next webinar is going to be on the 31st of October, and it's going to be on demand control ventilation. An email notification will go out this afternoon. If you're interested, please let us know. Other than that, have a great day, and thank you so much for participating in our Belimo webinar. Thanks, everyone.